Terry Hughes, director of the Australian Research Council's Centre for Excellence for Coral Reef Studies at James Cook University, tells Reuters on June 4th of 2020 that if global warming trends continue, the Great Barrier Reef will be destroyed. Due to rising ocean temperatures, with temperatures peaking at about 85 degrees Fahrenheit, according to the Australian Bureau of Meteorology, last accessed on March 1st of 2021, 2020 saw the Great Barrier Reef suffer the worst bleachings in history. The devastating effects of climate change can be seen everywhere. However, unlike forest fires or melting glaciers, the damage to coral reefs often goes unseen. Thankfully, there might be a solution, and it lies in a process known as acoustic enrichment. Acoustic enrichment attempts to use more natural restorative measures and could help revolutionize the way we've been thinking about reviving coral reefs. Renee Setter, biogeographer at the University of Hawaii at Maui, tells NBC in an article published on February 18th of 2020 that by the year 2100, there will likely be no remaining habitats for coral. Acoustic enrichment provides a solution. So today, we will start off by first dipping our toes into the water and uncovering the origins of acoustic enrichment and how the process works. Then we can analyze the effects it has had before finishing up and diving into some critical implications and limitations that come along with acoustic enrichment. But in order to fully understand acoustic enrichment, we must first talk about its history, and then we can talk about how the process works. In November of 2019, Nature Communications published the first study of acoustic enrichment using the Great Barrier Reef off the coast of Australia. The Science Times of December 1st, 2019 explains that the Great Barrier Reef spans approximately 1,500 square miles and suffered unusual back-to-back bleachings in 2016 and in 2017. These bleachings are essentially ocean heat waves that destroy coral reefs and make it hard for reefs to naturally restore. Acoustic enrichment attempts to revive these reefs and restore them to their original state. CNN describes the process in an article published on December 2nd of 2019. Essentially, scientists are able to place loudspeakers over portions of dead coral reefs and play the sounds of thriving coral reefs. That is actually able to stimulate growth within the reefs and can help the reefs naturally restore. While playing sound may seem unusual, it actually makes a lot of sense. According to EcoWatch on December 2nd of 2019, coral reefs are actually extremely loud places. With all of the fish, crackling shrimp, and great biological landscapes, a lot of noise is generated. And it's this noise that attracts young fish looking for a place to settle. So with acoustic enrichment, they're essentially trying to trick the fish into settling into the dead coral reefs. The fish would naturally avoid these habitats as they are not ideal for living. However, that sound emanated by the acoustic enrichment loudspeakers makes it seem as though the reef is alive and well. So the fish move in, and they're able to aid in the process of regrowth and restoration by repopulating the area once more. As Malgana Bay states on December 5th of 2019, healthy coral reefs and fish are mutually dependent on each other. While reefs provide fish with shelter and nooks and crannies to live in and reproduce, fish in turn graze upon the surface of coral reefs, allowing new spots for coral larvae to grow and settle. So, what is the impact of this happening? Acoustic enrichment has two primary impacts: increasing the fish population and encouraging biodiversity. So first, increasing the fish population. Phys.org of November 29th, 2019 explains that the Nature Communications study found that the fish population doubled in the presence of acoustic enrichment loudspeakers. And remarkably, the species of fish also increased by 50%. This is significant, as bringing back fish, especially diverse species of fish, is the first step into reviving coral reefs. And as the Washington Post of December 1st, 2019 explains, coral reefs that were treated with acoustic enrichment attracted fish faster and maintained fish longer than reefs that were not treated with acoustic enrichment. Science Daily of November 30th, 2019 explains that these species of fish that returned varied from all sections of the food web, from herbivores, detrivores, plankivores, and predatory piscivores. This leads us into the second impact of acoustic enrichment, which is encouraging biodiversity. According to the Sustainability Times of December 1st, 2019, biodiversity loss is an immediate threat that coral reef ecosystems face due to the delicate and intricate food webs that exist within coral reefs. But we are all connected. So if one part of the ecosystem is affected, the ripple effects harm all of us. According to the aforementioned Science Daily, it is vital to restore diverse species of both fish and coral into coral reefs, as each group provides a different function for the reef. But if ongoing trends continue and biodiversity is not brought back, these ripple effects will not only be felt in the coral reef ecosystem, but eventually in humans. And this leads us to discussing the role that acoustic enrichment can play on a wider scope. Current acoustic enrichment technology has two primary implications and one primary limitation. So first, the implications, one of which is the possibility to halt a humanitarian crisis. The New York Times of April 6, 2020 reports that millions of people across the world get their protein primarily from eating fish. Fish such as coral trout that live in coral reefs. But if ongoing trends continue and acoustic enrichment is not implemented, these species of fish will soon become extinct and can lead to hunger worldwide. But if acoustic enrichment is implemented, not only would we be saving coral reefs, but we would also reduce the chance of this happening. Additionally, acoustic enrichment has just started being used, and only in the Great Barrier Reef. According to the Coral Reef Alliance, last accessed on March 1st of 2021, coral reefs exist all across the world, spanning approximately 210,000 square miles. But unfortunately, as the Earth Institute at Columbia University explains, last updated on January 26th of 2018, 75% of these reefs are classified as endangered. So the fact that in limited sample sizes, acoustic enrichment has worked is promising and is area for hope. Further, the Smithsonian of December 3rd, 2019 states that if implemented on a large scale, acoustic enrichment has the potential to kickstart the natural recovery process that is necessary for saving coral reefs. But acoustic enrichment is not without its limitations. The Guardian of November 30th, 2019 explains that while acoustic enrichment fulfills the job of bringing fish back to dead coral reefs, it will not solve the crisis that coral reefs face on their own. The way to do that is to take bold, substantial action into ending climate change. Fortunately, acoustic enrichment still holds significance, as coral reefs that do have a fish population do stand a higher chance of being revived than those that do not, according to the Centennial source on December 9th of 2019. So instead, what is necessary is a hybrid of both restorative technology such as acoustic enrichment and bold, substantial action into ending climate change. So today, we have uncovered the origins of acoustic enrichment and how the process works. We have seen the effects it has had, and we have taken a look at some of the implications and limitations that come along with acoustic enrichment. Remember what Terry Hughes said: if global warming trends continue, the Great Barrier Reef will be destroyed. Dying coral reefs are just one example of the devastating effects of climate change. However, widespread implementation of acoustic enrichment may be the next step into saving coral reefs.